In this video, we'll look at higher order derivatives. So the derivative of the derivative we'll call the second derivative. If you take the derivative of the second derivative, we'll call it the third derivative, and so on. Okay? In Leibniz notation, it looks like this. So this is Leibniz notation versus Newton notation. So F double prime, F triple prime, F, and then you could put 4 slashes. Sometimes if you, the fourth derivative looks like with a little 4 in Roman numerals, as opposed to putting 4 slashes and 5 slashes and so on. Okay, but all it really means is the second derivative is just the derivative of the derivative. Okay, so it wants us to find y double prime, or the second derivative, f double prime x, or the second derivative of y with respect to x, for the following examples. So I always do the first derivative in red. So y prime, I'll use Newton notation, 6x to the fifth. All right, if I do the derivative of this, well, the derivative of y prime is y double prime. The derivative of 6x to the fifth is 30x to the fourth. Okay, pretty simple. F of x, I'll just clean this up, write it as a power function, and now I can do the derivative. F prime x, the derivative of this would be 10x to the first plus the derivative of this, 1/2 x to the negative 1/2. F double prime, the derivative of 10x would be 10. The derivative of 1/2 x to the negative 1/2 would be negative 1/4 x to the negative 3/2. Now, if I had to simplify these, okay, I'd probably call this one 10x plus 1/2 root x. And I don't think I'd bother getting a common denominator between those. I'd leave it as is. And I'd call this one 10 minus 1/4 times, and this would be the square root of x cubed, or x to the 3/2. Okay, it doesn't matter. You could write that as 4 times the square root of x cubed if you like. All good? All right, so this. Finally, f of x equals 2 minus x squared to the 10th. Well, f prime x, if I want to do the derivative of that, we know that this is a chain rule, so the 10 would come down in front of the bracket. I would rewrite the entire bracket, 2 minus x squared, subtract 1 from the original exponent, so 10 becomes 9, multiply by the derivative of what's inside the bracket. So what's the derivative of 2? Well, that would be a 0. What's the derivative of negative x squared? That would be a negative 2x. So instead of writing 0 minus 2x, I just write a negative 2x. And I will simplify this, negative 20x times 2 minus x squared to the 9th. So the negative 20x came from multiplying the negative 2x times the 10. And now, to do the derivative of this, I got to do a product and chain rule. All right, so this would be the first, or f of x, and this would be the second. 2 minus x squared to the 9th. So when I go to do the derivative of this, f double prime x, it would be the derivative of the first. Well, what's the derivative of negative 20x? That's negative 20 times the second, 2 minus x squared to the 9th. So there's f prime g plus, okay? So it would be plus f of x. So instead of writing plus negative 20x, I'll just write minus 20x. And then times the derivative of the second. Well, the derivative of this would be 9 times 2 minus x squared to the 8th times negative 2x. So from there to there, from the 9 to the negative 2x, that is the derivative of 2 minus x squared to the 9th. I used the chain rule. The 9 came down in front, rewrote the bracket, reduced the exponent by 1 to get 8, multiplied by the derivative of what's inside the bracket. And when I clean this up, I end up with negative 20 times 2 minus x squared to the 9th Negative 20x times negative 2x gives me positive 40x squared times 9. I missed that. Times this 9 here gives me positive 360x squared times 2 minus x squared to the 8th. And I can actually simplify this further. Remember when we combined product and chain, or quotient and chain, we often had to factor. All right? So f double prime x, if you ask yourself how many terms are in that line, there's one term right here, term 1, and there's a second term right here. So this is term 1, term 2. Well, what do they both have in common? All right, they both have a 20. I could take out a 20. Take out a negative 20 if you want it. And they both have a 2 minus x squared for sure. Well, what one do I take out? I have an exponent of 9 and an exponent of 8. The rule is you take out the lowest exponent. Now we are going to, all right, divide each term by this common factor. If I divide this by this, okay, I would be left with a negative 20 divided by positive 20 is a negative 1. 2 minus x squared to the 9th divided by 2 minus x squared to the 8th would leave a 2 minus x squared to the 1st. Okay, I won't write the exponent. Then I'm going to go 360x squared divided by 20. Well, 360 divided by 20, 36 divided by 2, that's 18x squared. Okay? And 2 minus x squared to the 8th divided by itself would be 2 minus x squared to the 0, which is just 1. Okay? So this term divided by that would just leave 18x squared. And then I'll just clean up what's inside the brackets. 20. That's a greasy 0. Fix that. 20 times 2 minus x squared to the 8th. And then in the brackets, this will become negative 2 plus x squared plus 18x squared. Okay, so I distributed the negative through both of these. And I end up with f double prime x equal to 20 times 2 minus x squared to the 8th. And then this one would be x squared and 18x squared, 19x squared minus 2. There it is. Okay, so some examples of how to find the first and second derivative. Remember, the second derivative is just the derivative of the derivative. Now, the first derivative of a function can be interpreted as the slope of a tangent line or as a rate of change. The second derivative can be interpreted as the rate of change of the slope of the tangent line. And that idea will be pursued later when we get into sketching curves. We will look at the second derivative when we get into curve sketching. It's an application of derivatives, curve sketching is, and we use the second derivative to find our intervals of concavity. Higher derivatives can be found, like the third derivative, just means find the derivative of the second derivative and so on. So here's an example where it asks us to find the first 5 derivatives. So I will say y prime is going to equal 4x cubed plus 6x squared minus 10x plus 3. Right, the derivative of the negative 6 would just be a 0. Y double prime would be 12x squared. That's the derivative of this. The derivative of this would be 12x. The derivative of this would be negative 10. And the derivative of this would be 0. Y triple prime, 12x squared. The derivative of that would be 24x. The derivative of 12x would be 12. Now, find a different color for y quadruple prime, or y, and you'll see this written. That's the fourth derivative of y with respect to x. 24x would be 24. The derivative of positive 12 would be 0. And the fifth derivative, Roman numeral 5, okay, rather than writing 1, 2, 3, 4, 5 primes, okay, you'll often see it abbreviated y with a v. And the derivative of that would be 0. So there are the first 5 derivatives. As I said, we will use like the first derivative as a ton of applications when we get into related rates and optimization. Second derivative has some application, in curve sketching too, for finding intervals of increase and decrease, we'd use the first derivative. The second derivative will be used when we get into curve sketching as well. Don't often have a whole lot of applications for the third and fourth and fifth derivatives, but sometimes you'll be asked a question to find the third derivative, like we are here. Okay, so for the following, we have f of x. Let's just change this so that we can set it up in order to use the chain rule. Okay, so 2 minus 3x under the square root is like saying 2 minus 3x to the 1/2. If I bring it up to the top, it would become a negative 1/2. Now I can do a chain rule. Negative 1/2 times 5 is negative 5 over 2. 2 minus 3x. Subtract 1 from the exponent, so I rewrote my brackets. Subtract 1 would give me negative 3 over 2. And then you multiply by the derivative of what's inside the bracket. So the derivative of 2 minus 3x would be negative 3. Now before I do the second derivative, I'm going to clean this up just a little bit. I'm going to call it 15 over 2 times 2 minus 3x to the negative 3 over 2. I'm not going to bother sending the 2 minus 3x to the power of negative 3 over 2 to the bottom, because I want to keep using the chain rule. Chain rule is much better than or quicker than the quotient rule. Okay, everyone okay with where the 15 over 2 came from? Negative 5 times negative 3 gave me positive 15. Now I'll do the second derivative. 15 over 2 times negative 3 over 2. So negative 3 times 15 is negative 45. 2 times 2 is 4. And then I would rewrite the bracket 2 minus 3x, close it, subtract 1 from the exponent. Negative 3 over 2 minus 1 is like saying negative 3 over 2 minus 2 over 2. So you'd get negative 5 over 2, and then you would multiply again by the derivative of what's inside the bracket. So that's a negative 3. F double prime x is going to equal negative 45 times negative 3. That's a positive. It'd be 120 and 15, so that's 135 over 4. 2 minus 3x to the negative 5 over 2. And again, I'm not going to bother bringing it to the bottom because I want to use the chain rule to get the third derivative, f triple prime x. Negative 5 over 2 times this 135 over 4. So negative 5 times 135, that would be 500, 150, and 15. So 650, 675 is what I would get, negative 675, mind you. 4 times 2 would give me 8. Okay, so negative 5 over 2 times 135 over 4 should give you negative 675 over 8. Rewrite the bracket. Subtract 1, negative 5 over 2 minus 1 would become negative 7 over 2. And multiply by the derivative of what's inside the bracket. Finally, I will just multiply the negative 675 times negative 3, f triple prime x. So if that was a 700 times 3, negative times a negative is a positive. 700 times 3 is 2100. And I'd have to subtract 325, 75. So 2100 minus 75, that would give me 2025. Okay, negative 675 times negative 3 is positive 225. 8 times 1 is 8. And I'd have 2 minus 3x to the negative 7 over 2, which I could write now that I'm done. Right, I don't have to find any more derivatives. It would be 2025 over 8 times 2 minus 3x to the 7 over 2, which you could write as, like this is fine with me, perfect, 2025, 8 times, this would be the square root of 2 minus 3x to the 7th. Also fine with me, both the same thing. Okay, so higher order derivatives. One more example, this one combines what we did in the last video with what we're going to do, or what we're doing today. So this is not in the form y equals, and if I tried to rearrange that, I'd still have y's on both sides, so I am going to do implicit differentiation. So the derivative of x times y, yikes. So I've got xy plus y squared equals 4. Remember, this means x times y, which would require a product rule. So the product rule would get you to take the derivative of the first. Remember, you're differentiating with respect to x. So the derivative of 1x would just be 1. So I don't even need to write the 1. Times the second. It would be 1 times y, which is just y, plus the first, so x. And then I got to differentiate y with respect to x. You can write it as y prime or dy over dx. Yesterday I was writing them as dy over dx. I'll write it as y prime today. It doesn't make zero difference. Okay. I find it's nice to write it as dy over dx, write it using Leibniz notation because you don't get confused. But here we can see I won't get confused. I promise I won't make a mistake. Okay, so y squared, the derivative of that would be 2y times y prime. And the derivative of 4 with respect to x would be 0. I'm going to leave the x, y prime, and 2y, y prime on the left. All right, and I'm going to subtract y from both sides, so I move this guy to this side. Then I'm solving for y prime, so I'm going to factor that out. It would leave x plus 2y in the brackets. So I divided this term by y prime to get x. I divided this term by y prime to get 2y. Now I'm going to divide both sides by x plus 2y. So I'd have negative y over x plus 2y. With me? Okay. Now, to do the second derivative, well, the derivative of y prime would be y double prime. And then to do this, I got to use a quotient rule. Okay, remember the quotient rule. F prime g minus f g prime all over g squared. Okay, so it's the derivative of the top. Well, the derivative of negative y would be negative 1y prime times the bottom, x plus 2y, or times g, minus the top, so minus negative y, so negative negative y, that would be plus y, times the derivative of the bottom. Well, the derivative of x would be 1. Remember, you're differentiating with respect to x. It's this term that's going to have that y prime in it. The derivative of 2y would be 2 times y prime, all over the bottom, which is x plus 2y to the power of 2. Now, I am going to replace this with this right here and this with this right here. That's what y prime is. So I will have y double prime equal to, this would be a negative y prime, so it would be, I'll just write this negative here, and then y prime is going to be negative y over x plus 2y. These negatives are going to cancel one another out. Okay, that's multiplied by x plus 2y. So you can see that's nice, that's going to change something here. Plus y times 1 plus 2 times this y prime is going to give me a negative y over x plus 2y. And I'm dividing by x plus 2y squared. Let me just drag that down a little. Okay, so the good news, this will cancel this, and I will be left with y prime equal to, that's just y. Y over x, y divided by x plus 2y times x plus 2y. Well, the x plus 2y's cancel, it leaves a y. Okay, this is going to give me a plus y. This would give me a negative 2y squared over x plus 2y. And all of this is over x plus 2y squared. So I end up with y double prime equal to There's 2y minus 2y squared over x plus 2y. And this is all divided by x plus 2y to the power of 2. Now, when I have a complex fraction, I like to multiply everything by a common denominator. So think about what's under this. There'd be a 1 there. So my common denominator would be 1 times x plus 2y, which is x plus 2y. And there's a 1 under this. So I'm going to multiply this term by x plus 2y. I'm going to multiply this term by x plus 2y. And I'm going to multiply down here by x plus 2y. And here's what I end up with. Okay, 2y times x is 2xy. 2y times 2y, that would be 4y squared. So that was me going like this. If I take negative 2y squared, divide it by x plus 2y, and then multiply it by x plus 2y, I'm left with negative 2y squared. On the bottom, they both have the same base. When you multiply powers with the same base, you write it down again, and you add the exponents. So this is an exponent of 2, this is an exponent of 1. Add them together to get an exponent of 3. And finally, I'll end up with y double prime equal to 2xy plus 2y squared. Okay, 4y squared minus 2y squared is 2y squared over x plus 2y to the power of 3. And that is great. You may see x plus y over x plus 2y cubed. Okay, 2xy, 2y squared. This is also fine. All right. It's nice to factor if there's something that, like, say there was a y down here that I could slash off, or there was a 2y down here and I could get rid of those and it would simplify things. It doesn't really simplify things to write it here like this, so I would mark this correct as well. Those are the questions you can try for homework.